definition of benzene. So just like when we studied the atom, there's different ways to represent the atom. Same with, there's different ways to represent benzene, and some are more accurate than others. So I'm going to tell you a little story. I like your bracelet.
Thank you.
So here's some tidbit info stuff. So benzene, just had to clear my throat. Okay. Benzene is an organic compound that puzzled scientists for a long time. Its chemical properties could not be explained by normal means. So, its melting point is 5.5 degrees and its boiling point is 80.1 degrees. And tests show that the molecule is nonpolar. No molecular evidence of triple or double bonds in the molecule. So there's no evidence of double or triple bonds in the molecule. So that's a big one, right? Because in order to get C6H6, you had to make a double bond. But there's no like data, if you did an experiment with it, that would give you indication that there's a double bond. However, with X-ray diffraction, it indicated that all carbon bonds are the same length. Now, if you get into more organic chem, double bonds and single bonds and triple bonds are different lengths. So that all carbons are equally spaced apart, that was kind of like, that's weird, right? Evidence from chemical reactions indicates that all carbons are identical and that each carbon is bonded to one hydrogen. So all this information doesn't really match up. So they tried to develop a diagram that would help represent this. So this was one of the first ones. So here you see carbons are all single bonded to each other, and then there's this random kind of floating valence electron inside. But that wouldn't work, okay? Because it wouldn't follow the octet rule, okay? Because each carbon has 1, 2, 3, 4, 5, 6, 7 around it. That doesn't work, right? So another theory is consistent with the 4 bonding carbon, but still doesn't explain some empirical evidence. So this is what you guys did today, right? Okay? So it fits, it works, so we have double bonds, but it's not a full, complete idea of benzene yet. So August Kekulé, however you say his name, was the one who came up with an accepted theory for the chemical structure of benzene that followed all accepted evidence. He proposed that the 18 electrons not involved in the bonding with the hydrogen are equally distributed around the carbon atoms. Okay? Therefore, the electrons that make up the second bond in the double bonds are equally shared. So it's like saying that these electrons that are all involved in these double bonds are like shared, they're passed around to all of the carbons all of the time. So it's not like, it's like taking these double bonds and putting them out here and then making them go in a circle or something. You know, like that they're not attached to one spot at one time. They go all the way around. What? That's crazy. Like, okay, so it's a sea of electrons. Kind of remember when we talked, where else did we talk about a sea of electrons? Metallic bonds, yes. So that those electrons, we say that they're delocalized, so that they can kind of spread around and you know, float, and everyone gets to share them, right? So we say that these electrons, these electrons behave in this way are called, where did I put that? I think I want to say delocalized. Yeah, I'll use that. Yeah, I think so. Yeah. Delocalized. They don't have one specific location that they have to be at. Each electron does not belong to one of the carbons, but are shared amongst all 6. So each carbon bond is equal in length and identical in nature. So how we represent this is we put a circle in the middle, right? Because that's what I was saying. If we took those, let's actually do that. That'll be fun. Oh no, they won't stick together. They don't. They can't stick together. Okay, but if I took those out, put them up here, made them in a circle. They ran out. Okay? So that's why we put a circle in the middle, and it's representing the electrons that go around and around. Okay? So, we say aromatics are compounds that contain a benzene ring. This is called a benzene ring. So things that have that are aromatic. Okay? What are aromatic compounds? Things that have... Great. Non-aromatic compounds are called what? We did that yesterday. It starts with an A. Aliphatic. Yeah. Now, the name aromatic was originally assigned to these compounds because the ones they discovered are ones that have a strong smell. So, aromatherapy, aromatic, right? That's what we think of strong smelling things. So things like pure vanilla or vanillin, right? The vanillin is a compound that makes vanilla. So it's very, it has a good smell, right? Naphthalene, okay? This is what's like mothballs, that's what that is made out of. Okay? So how do we name these things? So step 1, if a molecule contains a benzene ring, the root in the suffix is just benzene. Identify the prefix. 6 carbons in the benzene ring are numbered to locate the presence of more than one side group. Numbering continues in the direction of the nearest side group, so you want the smallest numbers possible. When a benzene is a side group, it is called a phenyl group. And I'll show you examples of that. So let's do some of these together. Okay, so here, this looks like, this is like the parent chain, you think of it, okay? So we have our benzene, so we know it's going to end in benzene. Then we see 2 methyls hanging out, okay? So I want them to have the lowest numbers possible. So if I go 1, 2, 3, or I go 1, 2, 3, 4, 5. So obviously 1 and 3. So I'm going to say 1, 3 dash dimethyl benzene. Okay. All right, next one. Again, this one will end in benzene. Put this up here. Will end in benzene because it's like everything is attached to the benzene group. That's how you tell if it's the chain or not. Okay. Here, there's an ethyl. Because it says C2H5, so that means ethyl. And then here's another ethyl. And here is a methyl. Okay, so I need the smallest numbering possible. So say, I don't know, we start here, 1, 2, 3, 4. Okay, that could work, 1, 2, 3, 4. So what I'm going to do is I am going to make the ethyl, this is 1, 2, 3, 4, because the ethyl is the first one written, so it's going to get the more priority numbers. So 1, 2, 3 dash diethyl dash 3 dash methyl benzene. Yes. Thanks. Okay. Now, look at the next one. When we look at the next one, everything isn't attached to the benzene, right? It's more like the benzene is attached to something else. So that's when we look at saying, okay, well, the parent chain would be this, and this is like a group that's stuck onto it. So we're going to call this a phenyl group, and our parent chain is an alkane. So let's count how many carbons in our parent chain. So we have 1, 2, 3, 4, 5, 6, 7, 8, 9. Okay, so that would be non-ane. Now I'm going to count from right to left because I can see everything's kind of grouped on this side of the chain, so I don't really need to try. So 1, 2, 3, 4, 5, 6, 7, 8, 9. Okay. So I have here, this is called a phenyl group, and here are 2 methyls. So which one comes first alphabetically? A, B, C, D, E, F, G, H, I, J, K, L, M, N, O, P, L, M, M comes first. Okay. Great job, everyone. All right, so what did I say comes first? M, right? Okay. So 3, 5 dash methyl dash 4 dash phenyl. Non-ane.
It should be dimethyl, right?
Yes! Oh my gosh. It certainly is. Sorry, thank you. Okay, let's try a couple where we have to draw the compound now. So draw 1,3-dipropylbenzene. So it says benzene is the last thing, so we start with a benzene big compound. Oh, not Augie. What was the joke? That's really badly drawn. Okay, so here, here, here. Okay, so that's a benzene. It's kind of awkward. Now 1 and 3 are propyls. Doesn't matter which carbon you pick to be your 1, but say I'm going to pick this one. So 1, 2, 3, and 1, 2, 3. It looks like a frog or something, you know, like those are the frog's legs. It's going sideways. What if it was 1, 2, 3, 4, 5? No, okay, let's say it was 4, 5 ethyl, okay? See, that is a frog. If I drew it as 4, 5 ethyl. That was fun. Okay, I put one of something like that on your quiz as a bonus, that if you can see a shape, if you drew it right. Anyways, I thought it was funny. Okay, so draw 4-ethyl 1,2-dimethylbenzene. So we start with our benzene. And again, it doesn't matter which one you pick as carbon 1. I'm going to pick this one. 1, 2, 3, 4, 5, 6. So a methyl here, a methyl there, and a ethyl there. Maybe that looks like Sputnik. Never mind. I'm just making stuff up now. Okay, you try naming these, and then we'll go through them. So just try it out, and then I'll help you. No.